Today's lesson is fraction and decimal clearing. We're going to do this problem twice. The first time we're going to do it the old way, and then I'm going to show you a better way of doing these problems, okay? So let's see. Old way of doing this is I would try to combine like terms first. I see the 3/4 and the 1/5 x. Right away, I notice that I really can't combine those because they have different denominators. So let me go ahead and get the same denominator. I'm going to do this on the side just so it doesn't mess up all my work, okay? So let me go ahead and start. 3/4 x plus 1/5. I want to take 3/4, I want to add it to 1/5. Unfortunately, I can't do that because they don't have the same denominator. So I'm going to try to find the same denominator between the two. I got a 4 and a 5. I can change both of those into 20. So I'm going to multiply the left by 5 over 5. That way I can get the 20 on the bottom. And for the 5 on the bottom, I'm going to multiply it by 4 over 4, so that way I also get the 20 on the bottom. So again, sorry, there should be an addition in the middle. So I'm multiplying the left by 5 over 5 and the right by 4 over 4. That way I can get the same 20 on both sides. 5 times 3, that's going to give me 15 over 20 plus, and then 1 times 4 is going to give me 4 over 20. Now, if you notice, they have the same denominators, and I can go ahead and add that together. I get 19 over 20 as my final answer to just adding those fractions. So I had to do all this extra work just so I can get those fractions written up, okay? All right, so what does that do? That combines this term with this term, and now when I add those two together, I get 19 over 20x plus 6 equals 2. All right, this is still a little ugly because I still have that fraction down there, but we can work with it. I'm going to go ahead and start undoing what's being done to the 19 over 20x, and that's being added by 6. So to get rid of the add by 6, I'm going to subtract by 6 on both sides. These are going to cancel, and I get 19 over 20x is equal to negative 4. There's two things being done to that x. It's being multiplied by 19. When you have a fraction, the top number is being multiplied and the bottom number is being divided. So I'm multiplying by 19 and I'm dividing by 20. Let me go ahead and get rid of the divide by 20 by multiplying by 20 on both sides. These are going to cancel, and I'm left with 19x is equal to negative 80. I'm almost done, but I'm running out of space, so let me write that again. 19x is equal to negative 80. Divide both sides by 19. These are going to cancel. I get x equals negative 80 over 19, and that is my final answer. As you can see, that took a lot of work, right? Because the fractions is what made everything pretty tough. So it says in the previous example, we have fractions where the denominator is 4 and 5. Remember that a fraction is really a division, so we are dividing by 4 and 5. This implies that we're dividing by 20. So to get rid of dividing by 20, we can just multiply by 20 instead. And that's the strategy we're going to use in solving these problems is we're going to try to clear the fractions. So steps to clearing fractions and decimals. First, we're going to simplify each side of the equation that does not include combining unlike fractions and decimals. What that means is simplify each side where it's easy, right? Don't try to do the side work that I did. Just simplify what you can that doesn't involve the fractions or the decimals. Unless it's super easy, then go ahead and do it. Step 2 is we're going to multiply both sides of the equation by the number that will clear all the fractions and the decimals. We'll show you what that looks like in a little bit. Step 3, we're going to simplify, and you should be able to solve the equation like we did in the previous sections. All right, so let's see what that looks like. We're going to go ahead and do the exact same problem we did before. Remember that we're dividing by 4 and we're dividing by 5. I want to find the least common denominator. The least common denominator between 4 and 5 is 20, or the least common multiple. You'll see it different ways. It doesn't matter. Uh, but between 4 and 5, I can change both of those into a 20. That means everything's going to get multiplied by 20. I'm going to multiply the whole left side by 20. And I'm going to multiply the whole right side by 20. What does that mean? That means every single one of these terms is going to get a 20 written in the front. That's going to get a 20. That's going to get a 20. That's going to get a 20. So it's going to be 20 times 3/4 x plus 20 times 6 plus 20 times 1/5 x is equal to, on the right side, it's just 40. All right, I know that looks way more complicated than what we had above, right? but it's not. And remember that right here, I'm doing two things. I'm multiplying by 3 and I'm dividing by 4. Both ways are going to work. You're going to get the same answer. If you multiply, and as soon as it's left to multiply first, don't do it. It's going to make the numbers bigger and it's not, it's more complicated than it needs to be. But you can multiply first. I'm going to take the 20, multiply it by 3, that's 60. And then 60 divided by 4, that's going to give me 15. So I would write 15x. The better way of doing it is to divide first. So we're going to take 20 divided by 4, because remember the number on the bottom means divide. 20 divided by 4 is 5, and then multiply it by the number on the top. 5 times 3 is 15. Either way, you're going to get 15x. Plus 20 times 6 is just 120. Here's another weird one, but that's okay. It's not really a big issue as long as you divide first. So we're going to take this 20. We're going to divide it by 5. That gives me 4. And then 4 times 1, that gives me a 4. And I still have an x. So I know the problem looked really difficult to begin with. But look at the problem now. It is so less complicated than it was before. Because again, if we clear the fractions by multiplying by the least common denominator, it gets rid of all your fraction and makes it a really easy problem. Now I'm just going to solve like I did before. I can combine the 15x with the 4x. That's going to give me a 19x plus 120 is equal to 40. Subtract 120 from each side. I get 19x is equal to negative 80. Divide both sides by 19. X is equal to negative 80 over 19. And this is the exact same answer we got before. But check it out, like there's so much less work there. I know it looked a little ugly, especially this step, right? Like this step is the one that usually scares students. But if you know what's going on there, where you're just really taking the number in the front, dividing, and then multiplying, it's really not that bad, okay? Let's try it again. We're going to go ahead and start off with this one. I'm going to first try to see if there's anything I can combine. I can't. I'm going to go ahead and clear the fraction. In order for me to clear the fraction, I need to find the least common denominator, or the LCM, the least common multiple. In this case, between 5 and 2, I can change them into a 10. What does that mean? That means I'm going to multiply the entire left side by 10, so all of that goes into parentheses. I'm going to multiply the entire right side by 10. Now that I have those, I'm going to go ahead and start distributing the 10. That means this 10 is going to go to the 5, and this 10 is going to go to the negative 2/5 x. This 10 is going to go to the 1/2 x, and the 10 is going to go to the negative 4. So when I write that, I'm going to write that as 10 parentheses 5 minus 10 parentheses 2/5 x equals 10 parentheses 1/2 x minus 10 parentheses 4. Notice all I really did was I put a 10 in front of everything. Looks really scary, looks ugly. I promise you, it should work out really, really nice. 10 times 5 is just 50. Here is where it gets complicated, but remember, all we're going to do is we're going to make the number small first by dividing. 10 divided by 5 is 2. And then we multiply it by the number on the top. 2 times 2 is 4. So what I'm left with is a negative 4, and don't forget your x, equal to. Here, we're going to take the 10 and divide it by 2. That's just 5. Take your 5, multiply it by 1. It's still 5. Don't forget your x, minus 40. All right, way easier than it looked before. Now that I cleared my fractions, I can go ahead and solve. I can't really simplify anymore, so I'm going to get rid of the smaller x. The smaller x is at negative 4x, so I'm going to get rid of it by adding 4x to each side. These are going to cancel. I'm left with 50 is equal to 9x minus 40. And then from here, it's just a two-step equation. So I'm going to go ahead and get rid of what's being done to the x. Right now, it's being subtracted by 40, so I'm going to add 40 to both sides. And then now the x is being multiplied by 9. I do the opposite. I'm going to go ahead and divide both sides by 9. I get x equals 10. I know I'm going really fast as far as the second parts. Hopefully, you're able to do that on your own. If you're not, make sure you pause the video and understand the steps that are being taken, okay? All right, on this one, I would love to clear the fractions, and you can, but me personally, I always like to distribute first because distributing is not that bad. So let me go ahead and distribute the 2/3 here and here. Hey, when I distribute those 2/3, I can't really multiply a number that's not a fraction, so let me make these into fractions, and it makes it easier to multiply. So I'm going to go ahead and multiply the top. That's 2 times 2. That's going to give me a 4 on the top. And then 3 times 1 is going to give me a 3 on the bottom. Don't lose your x. Minus 2 times 3, that's going to give me a 6 on the top. And then on the bottom, I have a 3 times 1. That's going to give me a 3 on the bottom. And that's equal to 2x minus 4. Now that I have it written like this, now I can go ahead and clear my fraction. What's the least common denominator between 3 and 3? Well, it's just 3. Like, you don't have to multiply those and make those 9 because they're both 3s. Um, I technically could combine those two if they didn't have that x and the constant, but the least common denominator between 3 and 3 is just 3. So I'm going to go ahead and multiply the whole left side by 3, and I'm going to multiply the whole right side by 3. What that means is this is going to get, oh, sorry, that was the wrong button. Let me go ahead and switch that. There we go. That means the first one's going to get a 3, this is going to get a 3, this is also going to get a 3, and that's going to get a 3. So let me stick 3's in front of everywhere. That's going to be a 3 times parentheses 4/3 x minus 3 times parentheses 6 over 3 is equal to 3 times parentheses 2x minus 3 times parentheses 4. Every single one of those terms got a 3. Again, this is a part where students get scared. They look at it, they say that's going to be really difficult. If you know the trick, it should be easy. Take 3 divided by 3, that's going to give me 1. 1 times 4 is just 4x. Minus, I'm going to take 3 divided by 3, sorry, that's going to give me 1. 1 times 6 is just going to give me a 6. 3 times 2x is 6x, and then 3 times 4 is 12. I got x's on opposite sides, so let's go ahead and get rid of the smaller x. I'm going to subtract 4x from each side. These are going to cancel. I'm left with the negative 6 is equal to 2x minus 12. I'm going to two-step equation now. It's going to add 12 to both sides. These are going to cancel. I'm left with 6 equals 2x. Divide both sides by 2, x equals 3. So we are done with the clearing of the fractions, okay? Now let's go ahead and focus on clearing of the decimals. In order to do that though, I need to give you a little quick reminder of what we did in the past. This is in the beginning of the school year. Remember that when you multiply a number by 10, all that does is it moves the decimal one time to the right. So for example, if I take 2.4 and I multiply it by 10, that's going to move the decimal one time to the right. If I multiply by 100, it moves the decimal 2 times to the right. If you multiply by 1,000, it moves the decimal 3 times to the right, and so on and so forth, right? Um, what happens if you multiply by 1? Well, it doesn't move the decimal at all. It stays the same, right? And that makes sense. All right, so let's take a look at this. I'm going to do like a pre-step, which is to figure out how many times do I need to move those decimals, so that way I'm not left with any decimals. Well, in this case, I would have to move the decimal once, and here I'd have to move the decimal once. This one doesn't need to move the decimal at all. So overall, let me put this in a thought bubble. I want to move one time, which means I need to multiply by 10. I need to move those decimals one time. That way I can get rid of the decimals. So everything is going to get multiplied by 10. So I'm going to multiply the whole left side by 10. And I'm going to multiply the whole right side by 10. Normally I would put a 10 in the front, but I'm just going to go ahead and just get this done. So 10 times 2.7, what's going to happen? That decimal is going to move one time to the right, and I'm going to get a 27. I'm going to continue distributing the 10. 10 times x is just 10x. And I'm going to distribute the 10 to the 2.9. 10 times 2.9, what happens? I'm going to move the decimal one time to the right, and I get 29. This problem is way easier to solve than the one that we just had, so I'm going to go ahead and subtract 27 from both sides. These cancel, I get 10x is equal to 2. Divide both sides by 10. These are going to cancel. I get x equals. Now, I would love to say that 2 over 10 is my answer, but remember that simplifies to 1 over 5. All right, and then that's it. So let's take a look at the next one. Same thing, I have a decimal problem. The decimal problem, we should really figure out how many times I need to move the decimal so that way I don't have decimals anymore. Let's see, I'm going to move this decimal once, twice. This one needs to move once. That one needs to move once. So how many times do I need to move the decimal to make sure that I don't have any more decimals? Well, I have to move them at least 2 times. So I'm going to move the decimal 2 times. If I need to move them 2 times, at least 2 times, right? Like if I move it once, I'm going to get rid of some of the decimals, but not all of them. If I move them 2 times, I'm going to get rid of all the decimals. If I'm going to move it 2 times, that means I'm going to be multiplying by 100. So let's go ahead and multiply this equation by 100. That means all the left is going to get multiplied by 100. And that means the whole right side is also getting multiplied by 100. I accidentally made a little mark. I don't want you to think that that's a decimal. It's not. Let me write that again. 100 times 0.1. Okay. Let's go ahead and distribute the 100 and see what happens. I'm going to take this 100, multiply it by 0.25x. What's going to happen to that decimal? It's going to move 2 times to the right. So my answer here is going to be 25x. I'm going to take 100 and multiply it times 0.6. That means I'm going to take that decimal, move it 2 times to the right, once, twice. Hey, I see a gap there. That gap is going to turn into a 60 because it turns into a 0 right here. In fact, let me write that in red so that it stands out. Because there's a gap right there, it's actually a 6 and a 0 now. Okay, so that's where I'm getting that 60 from. Equals. Same thing here. I have 100 multiplied by 0.1. I'm going to take that 100, distribute it. That's going to move the decimal 2 times, once, twice. My decimal is going to be here, and I have a gap here, so I'm going to put a 0 in its place, so that becomes 10. Now that I have this set up, let's go ahead and solve it. I'm going to subtract 60 on each side. These cancel. I get 25x is equal to negative 50. Divide both sides by 25. X equals negative 2. All right, we are down to our last problem. I got 0.02x plus 0.03 plus 0.05x equals 0.01. You can combine the x's or you can just clear the decimals right now. I'm going to go ahead and clear the decimals. If I'm going to clear those decimals, let's see, I need to move this one twice. I need to move this one twice. I need to move this one twice. I need to move this one once. So if I want to get rid of all the decimals, I got to move them at least 2 times. If I'm going to move it 2 times, then that means I need to multiply by 100. Okay, so let me go ahead and multiply the whole left side by 100. That's going to be 100 times 0.02x plus 0.03 plus 0.05x. That's the whole left side is being multiplied by 100 is equal to, I'm going to multiply the whole right side by 100 times 0.1. Everything is going to get that 100. So I'm going to take this 100, distribute it to the 0.02x. What happens there? I'm going to move the decimal 2 times to the right, and I get 2x plus. I'm going to take this 100, distribute it to the 0.03. What happens there? The decimal is going to move 2 times to the right. That's why I'm doing this. And now my answer is 3. I'm going to take this 100, distribute it to the 0.05x. What's going to happen to that decimal? I'm going to take that decimal, move it 2 times to the right. That's plus 5x is equal to, and then at the very end, I have this 100 multiplied by 0.1. That's going to move the decimal 2 times to the right. I see a gap there, which means I need to sneak in a 0. So 100 times 0.1 is just 10. Now I see that I have 2x's on the left side. I'm going to go ahead and combine like terms. 2x plus 5x, that's 7x plus 3 is equal to 10. And we have a two-step equation, so we're going to subtract 3 on each side. 7x equals 7. Divide both sides by 7. These cancel. I get x equals 1. Those are the notes for today. If you have any questions, please feel free to ask.